Hey Defenders, welcome back. In some previous videos, we went over installing our Honeypot, which is a project on GitHub called Teapot that serves as our universal honeypot and is a great way to easily stand up a honeypot solution within your environment. Whether you want to run it internally to try to pinpoint any malware that may have gotten inside the network or any malicious actors that may be on the network, or if you want to host it externally within like a DMZ or some other network that has public internet access just for research, you can do things that way. It's a great solution to be able to collect malware, collect APT group information, and is a great honeypot solution to do so. However, I realize in that video, we never worried about pumping that data to Wazuh and to our Elasticsearch cluster to alert us when some nefarious activity has happened across our honeypot. So in this video, we are going to integrate our honeypot with Wazuh to ultimately alert on those on specific alerts, and then to also log those within Elasticsearch so we can see them on the back end. So stick around and we'll jump into it. And alright, so I have my Wazuh instance here, and then I also have my honeypot instance here. And as you can see, I am currently not running Wazuh. So if I do a Wazuh agent, Wazuh is not installed, so we'll need to install it. But first, I want to show you guys kind of what logs we're going to grab. So the logs that I like to grab within this honeypot integration are Suricata logs. And so if we tail, see data, Suricata log, and then the eve.json file, we'll see Suricata alerts coming through. And these could be for, malicious certificates, any web application type of attacks, you name it. Suricata tracks a lot of network. Suricata is a network IPS solution, so anything that Suricata detects as potentially malicious will be written to this log file. And then the other one I like to query is this Cowrie, which is also a similar JSON file. So the directory for that is data Cowrie log, and then within that there's this Cowrie.json. And this is logging users who have attempted to SSH onto your box. So this is, especially if you're running this internally, this is a good way to see if maybe some internal actor is trying to access a box that they shouldn't be accessing. Maybe they're trying to probe the network and jump on and see what they can jump on to. So this is a really good way to detect. So the Cowrie logs are really good at logging what users have been trying to connect to the honeypotted SSH service. So that's good. And so what I like to do is use these two logs. So what I like to tell Wazuh once we install Wazuh on here is to gather these logs and forward them to our manager for analysis. So we'll first need to create a group before we install our Wazuh agent on here. So if I'm just going to take advantage of the default group, go into the repo here, and I'll post this in the description of this video as well. And I will paste this block here. Let me just cancel that because it's just running really slow. Let's try that again. Let me grab this out. And then we'll kind of walk through what we're doing. This shouldn't be too new though. If you guys have been following along for a while and familiarizing yourself with Wazuh, oh geez. Hopefully this shouldn't be new to you guys. So what we're doing is we're first specifying the log format. So that's a JSON output. So Wazuh knows that the logs that it's receiving are within a JSON format. And then we're pointing to the location of the log file that we want to collect. So again, we have the Cowrie log, and then we have the Suricata logs as well. Let me remove this. I don't know why this is reacting very slow to me right now. All right, so go ahead and save that off. And now let's go ahead and install our agent onto our Honeypot. This is a Debian box. If you use their ISO image, this will be a Debian 10 box. So instead of grabbing the CentOS operating system, we'll go ahead and grab the Debian one. This is a 64-bit, so I'll say that. My server for my manager, or the IP for my manager is this guy. Yep, that looks good. I'll put them in the default group because that's where we created that. If you want to create a new like Honeypot group and then put that log configuration, which is this guy within that group, that's perfectly fine too. And then I'll go ahead and copy this guy and run it on the Honeypot server. All right, and that looks good. And let's go ahead and kick it off. And then, oh yeah, you'll see it's probably hard to tell on this blue and on black, but during the Honeypot install, it creates like a random host name. And this one is convincing bronchitis. Huh. Interesting. But that's just done randomly. Of course, after installing the Teapot software, you can edit the hostname within the etc hostname file and just create it to a hostname that matches the naming convention of your environment. So it's not too obvious that this is a Honeypot server. So let me go ahead and tell the osec.log just to make sure that this has connected. It looks like it has. Okay, good. So if we refresh here, we should see our guy. All right, and that looks good. And then we should, if we go into configuration, and so now if we go down into log collection, we should see our 2 logs. And yeah, here we go. So we see the 2 that we've added just to confirm that the Wazuh agent is picking these up and forwarding these correctly. So that looks good. However, we're not going to see anything within our like security events because we don't have any rules created with this yet. So what we'll need to do is create rules within our Wazuh Manager that will trigger based on the logs that we receive. So if we go back into our GitHub here I've just created some dummy rules that you guys can copy and play around with and use in your own environments, and we'll kind of walk through what these are doing. So if I go into management, go into rules, I'll select manage rules, and then custom rules here, and I'll select the edits, and I'll just create a new group here, paste that in. 48, what happened here? So that looks good. And let me actually remove their default one because it's gonna have a number constraint. And okay, let me go ahead and duplicate this out, and we'll kind of walk through what we're doing here. Because you see the first rule that I have, we have an if signature ID statement of 86,601, and what this block will do here is parse for Suricata alerts. So again, if we jump on our Honeypot here, if we scroll up to where we are having our Suricata alerts, these guys here, we need to create a Wazuh rule that captures these events. So by default, Wazuh actually has a Suricata alert rule ID, this 86,601. However, what I like to do, especially if you're deploying multiple honeypots, is giving them their own kind of group. So I like to group the Suricata alerts per honeypot together. And how I like to do that is by using the if signature ID. So we're creating a new rule that fires only if this rule has fired, and also if it matches a particular host name. So if we go back into our agent here and we just select the security events and we'll parse these out, we'll see the host name or agent.name field that comes in with all of our logs. So if we expand one of these guys out, we see this agent.name, and here it is, this convincing bronchitis. It's an interesting name. So I can copy this guy, and that'll be what this value, what I'll change this value to here. So now this is saying, hey, I want this rule to fire if it's a Suricata alert, right? But because it's the 86,601, and if the host name of the agent that's sending the alert is this convincing bronchitis one. This allows us to now add multiple honeypots within our environments and then kind of group the alerts per honeypot together, which is nice. And then, so that looks good. And then we start to climb down the chart here, or climb down the rules here. And now we're going to actually trigger different Suricata alerts based on the alert severity of the Suricata alert. So if you can see here, we have a new rule ID, 100,014 is going to fire if the rule ID 100,000 fires, which again, if that rule ID fires, then we know it's a Suricata alert and we know it is this convincing bronchitis honeypot server. And then we're going to look at the field name and grab what the alert.severity is. So if we look at a Suricata alert here, so if we look at one of our Suricata alerts on the honeypot, we'll see this field here, severity 3. And so that's what this rule is checking against. It's checking against what is the value within the alert.severity field. If it's a 3, then okay, I'm going to trigger this rule saying honeypot Suricata alert severity 3, and then detail out the alert signature, the source IP, and then the destination. And then these other two rules below it are doing the same thing, just for the different severity numbers. So here we have severity 2, and then here we have severity 1. Again, by default, Suricata's hierarchy of severities, 3 being the lowest and 1 being the highest. And then our last group here will be for the Cowrie logs. So what we're going to do is, or what we're stating here is, I've just created a rule ID. This is a much higher number, so that if I want to add more honeypot servers and then grab their Suricata alerts, then I don't have to, I'm not stepping on any toes by having to create another unique rule ID. I can just increment by 1. It's a little bit easier to manage. But here we're going to decode the field as JSON because it is the Cowrie.json log that we're receiving the alerts from. And then we're going to look at the field name event ID that comes in within the log. We're going to look for the Cowrie login failed. So if we look at this guy here, and let's just grep for failed, then we should see something like this. So again, what we're saying to match is, hey, I want the event ID to equal this Cowrie login failed. And so if we look at the log here, we have event ID, and then sure enough, this would match off of that. So that looks good. So let's go ahead and save. That looks good. And restart. And then we'll go ahead and run a rule set test. We'll use one of Wazuh's 4.2 new features. If you haven't seen my Upgrade Wazuh video, I guess I'll shamelessly plug that now. Check it out. I'll put a link to it in the top right of the video. So go ahead and check that out if you haven't already. And once this restarts here, we'll be able to test our rules. So I'll just go ahead and copy this guy, and then we'll paste it in, and hopefully we will get our expected result. All right, so that all looks good. So let's go ahead and select this rule set test, and I will test. And sure enough, we get our rule ID to fire with description. User tried to log into Honeypot. Oh, the username is actually user for this log. So whatever bot or human was trying to log on to this, we see that here. All right, so that looks good. Let's see if we can do the same for a Suricata log. This one may give us an error because it won't, not an error, but it'll probably trigger the 86,601 because it doesn't know the host name of where this event is coming from. So, we created our first rule within the chain here was to fire off of the agent name convincing bronchitis, where here that's not going to be part of the log, so it's probably just going to trigger the 86,601, and that is the case. So, okay, that's fine. We don't have the best way of testing that, but what we can do is just go back to our agent here, and let's see if now we're starting to get some alerts. So I'll just go ahead and go into security events. I'll just tail the Suricata log. Okay, yeah, so a lot of them are generating, so we should start to see some here. And if I go into events, and okay, yeah, here we go. Immediately we see someone's running a nmap scan against our honeypot server. And again, if we follow the rules, so as part of the rules that we created, I'm setting variables for source IP and destination IP. So now, as part of the alerts, those values are getting auto-generated. Those values are becoming a part of the rule description, which is nice. Let me filter out this promiscuous sniffing mode one, so we're not just getting spammed with that. But now as you can see, we are now able to now store our Suricata logs that we're getting from our honeypot. We're writing them to Wazuh, and then Wazuh is, depending on the log entry that we received, is storing them within Elasticsearch. And then from this we can create some outbound alerting, such as, okay, so now if a Suricata Severity 1 alert triggered on our honeypot, let's go ahead and send an email out to the security team saying, hey, something nefarious could be going on here. Let's see if we can now generate some Cowrie alerts. So if we just grep this out, let me see if I can just generate one of these myself. So if I connect to this guy on port 22, I should get prompted for a username. So I'll just log in as OpenSecure, and I'll just give a password of please subscribe. And sure enough, as soon as we do that, we have our username here, OpenSecure, and then our password as please subscribe. I will say, fair warning, especially if you're doing this internally, especially if you're hosting this internally, user passwords will come in clear text. As part of the SSH honeypot service that they duplicate, that they replicate, the main idea of this is to capture the username and the password that someone is using. So any legitimate users that, maybe they're part of your operations team and they're doing updates or something like that and try to just log on to this box, especially if they log on to port 22, is the port where the replicated SSH service is listening on. For any legit authentications, if you actually do need to SSH onto this box, it is on port 64295. So if you see here, so just make sure your operations team or anyone who's looking to interact with the Suricata box knows that, or else their passwords will be logged in clear text here. And if we do a refresh, because now that log should have been stored into Elasticsearch here. So bear with me while this loads. And here we go. Here we see our entry for OpenSecure tried to log into Honeypot. And if we scroll down, we see the password that I used as please subscribe. So just a fair warning of that, any legitimate users, their passwords will be saved in clear text. So just be cautious of that. And then we're also getting the source IP, which is cool. So this is my external IP address that's given from my ISP provider. But now we're able to see, okay, this user tried to log in with this password from this address, now, especially if we're hosting this internally, what you could say is, okay, do I see this user, let's open secure in this example, trying to log on onto any other internal servers? And you would, of course, see that within our Wazuh logs for, user failed or user successfully logged in. You can take this data that we're collecting from our honeypots to really kind of pivot across alerts within our internal networks. And now this way we're pumping them into our collective SIEM, rather than if you have followed my previous video and stood up the Teapot honeypot on its own, it actually by default installs Elasticsearch and Kibana and logs all of its logs within alert and logs all of its alerts within there as well. But of course, that just means you have to now maintain a separate elk stack, which we don't necessarily want to do. We want to manage our one full collective SIEM elk stack and pump all of our alerts into this guy. And so now we can easily do that, which is really nice. I think that wraps it up for this video. I appreciate you guys hanging out with me, and I will see you in the next one.